Welcome to Module 3 of Mechanics and Materials Part 1. Today's learning outcomes will be to discuss one of the concepts that I talked about at the beginning of the course, stress, and we're going to define and discuss normal stress and shear stress. So here's where we left off last module with an axial centric load on an engineering structural member. So here's the axial centric load being applied to our structural member. And again, this structural member may have a circular cross-section, it could have a rectangular or square cross-section, or perhaps an I-beam, as long as the load is axial and going through the centroid of the cross-section. We can then do cuts to look at the internal forces developed in the member. This is a transverse cut, and when I do a transverse cut, I can reveal a potential of up to two orthogonal forces on the cross-section, an N force and a V force. In this case, if we look at equilibrium in the y direction, we see that for a transverse cut with axial loading, the V force is going to go to 0. But then I can also do a non-transverse cut. And when I do a non-transverse cut, I end up with a normal force, which we're going to label as N. And again, a shear force, which we're going to label as V. And combined, they balance out the P force, the external force on the left. So let's look closer at this non-transverse cut. On this cross-section, we're going to develop what's called normal stresses, or sigma, which is the force per unit area perpendicular to the cut surface. And so here's a graphic of that normal stress. And so sigma is going to be defined as the total normal force divided by the cross-sectional area. And we're going to assume that that force is uniformly distributed across around the cross-section, and so it's going to be also termed the average stress. And because we're doing a transverse cut, we also talk about this as being stresses on an inclined section or a plane. And the sign convention will be that if the stresses are in tension and the force is in tension, that's a positive normal stress. If we're in compression, then that's going to be a negative normal stress. In addition to the normal stress, we also develop something called shear stress, and it's given the symbol tau. And it's the force per unit area parallel to the cut surface. And here again is a graphic of that. And so the shear stress is equal to the force V divided by the cross-sectional area. And again, we're going to assume that it's uniformly distributed across the section. And so therefore it'll be the average shear stress. So now I want you to do a worksheet on your own to apply these principles that we've just discussed. We have a flat steel alloy bar. It's a rectangular cross-section with the dimensions given. It has an axial load. It's a centric load, 60 kilonewtons. And I'm asking you to determine the normal stress and the shear stress on the bar for both the transverse cut and the non-transverse cut, or the inclined plane. And when you finish that up, I have the solution in the module material.